Welcome to another episode of learning. I thank each one of you for watching my videos all these years and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that have appeared in the JEE Main examination held in the January 2025 session. And in this video, we discuss the solutions of the problems from the section Binomial Theorem. 3 videos are dedicated for Binomial Theorem, out of which this is the first video out of the 3 videos on Binomial Theorem. Right. This is the question that has appeared in the JEE Main exam held on 28th January 2025 in the morning shift. The given question is, if alpha is equal to 1 plus sigma r is equal to 1 to 6 minus 3 to the power of r minus 1 multiplied by 12c 2r minus 1, then the distance of the point 12 comma root 3 from the line alpha x minus root 3y plus 1 is equal to 0 is. It is a numerical answer type question. Right. We have to first of all find what is alpha. Let's now discuss the solution of the problem in detail. We have alpha is equal to 1 plus sigma r is equal to 1 to 6 minus 3 to the power of r minus 1 into 12c to r minus 1. It is a very typical question. Right. So for this, what we write is 1 plus sigma r is equal to 1 to 6. For minus 3, we have written I root 3 square. I root 3 square is I square is minus 1, root 3 square is 3. So minus 3 to the power of r minus 1, 12c to r minus 1. So that is equal to 1 plus sigma r is equal to 1 to 6. I root 3 to the power of 2r minus 2. Because r minus 1 into 2 in the powers into 12c to r minus 1. Right. So that is equal to 1 plus sigma r is equal to 1 to 6. In this I root 3 into 2r minus 2, 1 I root 3 to the power of minus 1 is taken out. That will be 1 by I root 3. What will be left? The leftover is I root 3 to the power of 2r minus 1, 12c to r minus 1. So 1 by I root 3 will be a constant. It will come out. That is equal to 1 plus 1 by I root 3 sigma r is equal to 1 to 6 multiplied by I root 3 to the power of 2r minus 1 multiplied by 12c to r minus 1. Right. So that is equal to 1 plus 1 by I root 3 sigma r is equal to 1 to 6 12c to r minus 1 into x to the power of 2r minus 1, where x is I root 3. This we have substituted for easiness. Writing I root 3 always will be tedious thing. Right. So this is equal to 1 plus 1 by I root 3 into expand this one. R is equal to 1, 12c1x. R is equal to 2, 12c3x cube. R is equal to 6, 12c11 x to the power of 11 at the end. So what are you looking at? These are 1, 3, 5, 11, they are all odd. They are suggesting something, right? So we take 1 plus x to the power of 12. So this will be 1 plus 12c1x plus 12c2x square plus so on and so forth plus 12c11x to the power of 11 plus 12c12x to the power of 12. 1 minus x to the power of 12. So alternately my positive, negative will come. And what is that we want? We want 12c1, 12c3, 12c11. So subtract. If you subtract 1 plus x to the power of 12 minus 1 minus x to the power of 12, then this 1, 12c2 x square, 12c4 x to the power of 4, they cancel out and you are left with 2 times of 12c1x plus 12c3 x cube plus so on and so forth plus 12c11 x to the power of 11. So that is precisely this one. So this is equal to 1 plus 1 by I root 3 into 1 by 2 into 1 plus x to the power of 12 minus 1 by 1 minus x to the power of 12. Agreed? Agreed? So now this is equal to 1 plus 1 by I root 3 into 1 by 2, yes, 1 by 2 is there, 1 plus, for x, I root 3 you substitute, 1 plus I root 3 to the power of 12, 1 minus 1 minus I root 3 to the power of 12. The presence of this 1 plus I root 3 and 1 minus I root 3 will suggest you there is somewhere the cube roots of unity are working out. So that we do it in the next slide. Right, this is what we have done so far. So now, what are the cube roots of complex cube roots of unity? The complex cube roots of unity are minus 1 plus I root 3 by 2 is omega and minus 1 minus I root 3 by 2 is omega square. So this will be minus 1 plus I root 3 to omega minus 1 minus I root 3 to omega square. But what is that we want? We want 1 minus I root 3 will be minus 2 omega and 1 plus I root 3 will be minus 2 omega square. So these things you substitute here. 1 plus 1 by I root 3 into 1 by 2 into 1 plus I root 3 to the power of 12. 1 plus I root 3 is minus 2 omega square to the power of 12 minus 1 minus I root 3 is minus 2 omega to the power of 12. Now omega square to the power of 12 is omega to the power of 24 and omega cube is equal to 1. Therefore omega to the power of 24 is 1. Omega to the power of 12 is also 1. So thus we get 1 plus 1 by I root 3 into 1 by 2 into 2 to the minus 2 to the power of 12 is 2 to the power of 12 minus 2 to the power of 12 is 2 to the power of 12. 2 to the power of 12, 2 to the power of 12 cancels and we will get 0. For 1 plus 0 is 1. So the answer for alpha is 1. Thus we got the line. In the line we have a alpha. The value of the alpha is 1. We got it. Thus alpha is 1. The given equation of the line is 1 alpha x means 1x minus root 3y plus 1 is equal to 0. What is that we want? We want the distance of this point 12 comma root 3 from this straight line. Now the distance of the point 12 comma root 3 from the line x minus root 3y plus 1 is equal to 0 is, you know the distance formula. Distance of a point from a given line is modulus of ax1 plus by1 plus c by under the square root of a square plus b square. This is the distance of the point x1 y1 from the line ax plus by plus c is equal to 0. So precisely, so wherever there is x you substitute 12 and wherever there is y you substitute y and you work out this one. Mod of 12 minus root 3 into root 3 plus 1 by under the square root of the coefficient of x square. So that 1 square plus the coefficient of y square root 3 square, that is modulus of 12 minus 3 plus 1 by 2, that is equal to 5. The answer to this question is 5. Right. We move to the next question. This question has appeared in the JEE Main exam held on 23rd January 2025 in the morning shift. The given equation is the sum of all rational terms in the expansion of 1 plus 2 to the power of 1/3 plus 3 power 1 by 2 whole to the power of 6 is equal to. Let's now discuss the solution of the problem. It is a question related to the multinomial theorem. We have by multinomial theorem x1 plus x2 plus etc. plus xk whole to the power of n is equal to sigma n factorial by alpha 1 factorial into alpha 2 factorial etc. alpha k factorial into x1 to the power of alpha 1 into x2 to the power of alpha 2 etc. xk to the power of alpha k, where the alpha 1, alpha 2, alpha k are non-negative integers such that alpha 1 plus alpha 2 plus alpha k is n. Right. So, now 1 plus 2 to the power of 1/3 plus 3 to the power of 1 by 2 to the power of 6 is equal to sigma 6 factorial by n factorial, 6 factorial by alpha 1 factorial into alpha 2 factorial into alpha 3 factorial multiplied by 1 to the power of alpha 1, 2 to the power of alpha 2 by 3, 3 to the power of alpha 3 by 2. So, where alpha 1, alpha 2, 3, alpha 1, alpha 2, alpha 3 are non-negative integers such that alpha 1 plus alpha 2 plus alpha 3 is equal to 6. These combinations you have to work out properly. Right. Now, you may observe this one. To obtain rational terms, that means we do not want irrational terms, we have to choose alpha 2 as a multiple of 3. Alpha 2 as a multiple of 3, then you will get a non-negative integer and thereby you get a rational term. 2 to the power of positive integer or a non-negative integer will be rational. And alpha 3 must be taken as a multiple of 2. So, alpha 2 a multiple of 3, alpha 3 you have to take as a multiple of 2 in addition to the above conditions, that is alpha 1 plus alpha 2 plus alpha 3 is equal to 6. This will take a little more time to compute all such combinations and then compute the coefficients. It will take time. That I will show you in the next slide. Right. So, we take alpha 1, alpha 2, alpha 3 such that they are non-negative integers such that alpha 1 plus alpha 2 plus alpha 3 is equal to 6. Here we have a tabular form ready-made for you, alpha 1 and alpha 2. What should be the choices for alpha 2? It should be a multiple of 3. 3 must divide alpha 2. So, what are the choices for alpha 2? 0, 3, 6. Then only 3 divides them. And alpha 3, what are the choices? 2 must divide alpha 3. So, the choices are 0, 2, 4, 6. In such a fashion that alpha 1 plus alpha 2 plus alpha 3 is equal to 6. Then compute the coefficients. 6 factorial by alpha 1 factorial, alpha 2 factorial, alpha 3 factorial into 1 to the power of alpha 1, 2 to the power of alpha 2 by 3, 3 to the power of alpha 3 by 2, and compute this and write down here. So, first one we take alpha 1 is 6. If alpha 1 is 6, alpha 1 plus alpha 2 plus alpha 3 must be 6, then what should be alpha 2, alpha 3? 0, 0. Then alpha 1 is 6. And alpha 2 is 0, alpha 3 is 0, substitute here. 6 factorial by 6 factorial, 0 factorial, 0 factorial into 1 to the power of 6, 2 power 0, 3 power 0, that is 1. So, 6 factorial by 6 factorial is 1. So the 1 is the answer. So now with the 6, the possibilities are we have exhausted. Let us take next possibility 4. Now one may ask a question, sir, why not 5 we take? Alpha 1 is 5. When alpha 1 is 5, you don't have a 1 for the choice of alpha 2, 1 in the choice of alpha 3. Therefore, that 5 will not work for you. So alpha 1 is 4. So let us take alpha 2 is 0, alpha 3 is 2. So alpha 1 plus alpha 2 plus alpha 3 is 6. Substitute here. So reading all every time is very difficult. So 4 factorial and 0 factorial, 2 factorial. So that means 1 to the power of 4, 2 to the power of 0, 3 to the power of 2 by 2, 1. That is 3. That is 3. And 6 factorial by 4 factorial into 3 compute. That is 45. Now what are the other possibility? Now one may ask a question, sir, we take 4, 3 here, 4 plus 3, 7, it doesn't work. So therefore the only possibility that can be taken for alpha 1 is equal to 4 is this combination only. So alpha 1 is 3, alpha 2 3 and alpha 3 is 0, 3, 3, 0, 6. So this is what we get and this is 40. Now 2 with the 3 we have exhausted the, with the 2, 0, 4. This is the possibilities 135. And one may say 2, 3, we don't have a 1 here. Therefore, no combination. 1, 0 if you take 1 plus 0, 0, 1, we don't have a 5 for alpha 3. Therefore, we have to start with the next one, 1, 3, 2. So substitute here. You get 360. Now alpha 1 is 0, alpha 2 is 0, alpha 3 is 6. Yes, it works. We will get 27. And 0, 6, yes, 0, 6, 0. It works here. Thus we have exhausted all possibilities. All possibilities we have exhausted. And that's what I am telling. That taking all such combinations and computing these coefficients will be a difficult job in the examination. And I don't think many of you have worked this question. And it is not difficult. It will be tedious and it will take long time. Now, sum of all the rational terms is so many terms, 1 plus 45 plus 40, so on and so forth. When you add all these things, you will get 612. Therefore, sum of all rational terms is 612. The answer to this question is 612. That is the detailed discussion of the solution of this problem on multinomial theorem. Right. This question has appeared in the JEE Main exam held on 22nd January 2025 in the second shift. Right. If sigma r is equal to 1 to 30 r square into 30 cr whole square by 30 cr minus 1 is equal to alpha multiplied by 2 to the power of 29, then alpha is equal to. So given this is equal to alpha into 2 to the power of 29. So this implies alpha into 2 to the power of 29. We have written sigma r is equal to 1 to 30 r square into 30 cr by 30 cr minus 1 multiplied by 30 cr, because we have 30 cr whole square in the above. Agreed. Agreed. Recall this result, ncr by ncr minus 1 is n minus r plus 1 by r. Use that here. Sigma r is equal to 1 to 30 r square into 30 cr by 30 cr minus 1 is 30 minus r plus 1 by r into 30 cr formula 30 factorial by r factorial into 30 minus r factorial. Now cancel. This r cancels with r square r times. This r cancels with r factorial r minus 1 times. You will get 30 into sigma r is equal to 1 to 30 minus r plus 1 into 30 factorial by r minus 1 factorial into 30 minus r factorial. Out of this 30 factorial, we have written a 30 here and kept 29 factorial here. And 30 minus r and 30 minus r is telling you something, therefore we will separate them. 30 into sigma r is equal to 1 to 30, 30 minus r into 29 c 30 minus r. This one is 29 c 30 minus r plus 1 times sigma r is equal to 1 to 30 of 29 c 30 minus r. Agreed. This 30 minus r is telling something. So we change the variable of summation from r to s. So put 30 minus r is equal to s is the new variable. R will be equal to, when r is 1, s is 29. When r is 30, s is 0. Then the above will be 30 into sigma s is equal to 1 to 29. 30 minus r, s into 29 cs plus sigma s is equal to 0 to 29. Sigma s is equal to 0 to 29 cs. Agreed. We recall a result. Sigma r is equal to 1 to n, NCR. The sum of all the binomial coefficients in the binomial expansion is 2 power n, and sigma r is equal to 1 to n, r multiplied by NCR is n times 2 to the power of n minus 1. And for the first one, that is sigma s is equal to 1 to 29, s into 29 cs, you use the second result. That is 29 into 2 to the power of 29 minus 1, 28, 30 times, plus the sum of all the binomial coefficients is 2 to the power of 29. And now 2 to the power of 28, you take out common, 30 into 2 to the power of 28 into, in the first one you get 29 out, plus 2, the excess to what we have written here. This is equal to 30 into 31 into 2 to the power of 28. Right. And this is alpha into 2 to the power of 29. But we want alpha. Therefore, alpha will be 30 into 31 into 2 to the power of 28 by 2 power 29. 2 power 28 cancels both in the numerator and denominator. You will get 30 into 31 by 2, that is 15 into 31, that is 465. Therefore, the answer to this question is 465. That is the detailed discussion of this question. Right. We move to the next question. And this question has appeared in the JEE Main exam held on 22nd January 2025 in the morning shift. It will also take time, because understanding them and using the appropriate results, I think this will take time and it will be tedious in the exam. If sigma r is equal to 0 to 5, 11 c 2r plus 1 by 2r plus 2 is equal to m by n, where GCD of m comma n is 1, that means m and n are relatively prime, then m minus n is equal to. Let's now discuss the solution of the problem in detail. Sigma r equal to 0 to 5, 11 c 2r plus 1 by 2r plus 2 is equal to m by n, where GCD of m and n is 1. Now expand this. R is equal to 0, 2r plus 2 will suggest you the denominators will be even. 11 C1 r is 0 by 2, r is 1, 11 C3 by 4, r is 2, 11 C5 by 6, plus etc. r is 5, 11 C11 by 12, that's equal to m by n. And the denominators 2, 4, 6, 12, they all tell you. And once you are getting a denominator, there is somewhere some integration must take place. Right? Some integration must take place between a integral 0 to 1 or integral minus 1 to 0. Something should happen. So, what we first take is 1 plus x to the power of 11 is this expansion. Now, what we do is integrate with respect to x. So, integrate this. This will be integral of 11 c naught x plus 11 c1 x square by 2, 11 c2 x cube by 3 plus etc. 11 c11 x to the power of 12 by 12. That's what we got. And on the left hand side, 1 plus x to the power of 11, when you integrate, it is 1 plus x to the power of 11 plus 1, 12 by 12. And on the right hand side is this one. Now integrate this one, integrate between the limits 0 to 1. So, you have already integrated, just put between the limits 0 to 1. So, 1 plus x to the power of 12 by 12, x is equal to 0 to 1, and all that from x is equal to 0 to 1. Now, for the upper limit 2 to the power of 12, for the lower limit it is 1 by 12 into, for the upper limits 11 c0 plus 11 c1 into 1 by 2 plus 11 c2 into 1 by 3 plus etc. 11 c11 into 1 by 12. Call this as the equation 1. Right. You take the integral, the above integral itself. Now evaluate this integral between the limits minus 1 to 0. So the integral as it is, but put the limits, lower limit minus 1, upper limit 0. So that will be 1 plus x to the power of 12 by 12, x is equal to minus 1 to 0, and all this one between the limits x is equal to minus 1 to 0. For the upper limit, it is 1 by 12. For the lower limit, for the upper limit, it is 1. For the lower limit, it is 0. So 1 minus 0 by 12. For the upper limit, it is all 0 because every term is involving x minus in brackets 11 c0 x is minus 1 minus 11 c1 x square by 2 minus 1 square by 2 1 by 2 11 c2 1 by 3 11 c11 minus 1 to the power of 12 by 12. So this is what we got, and this is 1 by 12 into 11 c0 minus 11 c1 1 by 2 plus 11 c2 1 by 3 minus so on and so forth. 11 c10 one term before this also I have written 1 by 11 minus 11 c11 into 1 by 12 is 2. So write down these two. We have written all this. What is that we want? Subtract second from the first. Then you will get 1 by 2, 1 by 4, so on and so forth. This will be 2 to the power of 12 minus 1 by 12 minus 1 by 12. 2 into, the first term cancels. The second term, 2 times of that, 11 c1 into 1 by 2. Third will cancel. The fourth will be 11 c3 into 1 by 4, so on and so forth. At the end, you will get 11 c11 1 by 12. Right. Now, this will imply 2 to the power of 12 minus 1 minus 2 by 12 is equal to 2 times 11 c1 into 1 by 2 plus 11 c3 into 1 by 4 plus etc. plus 11 c11 into 1 by 12. that is equal to 2 to the power of 11 minus 1 by 12. Why? This 2 we are cancelling. This 2 we are cancelling is equal to 11 C1 by 2, 11 C3 by 4 plus 11 C11 by 12. That is precisely sigma r is equal to 0 to 5, 11 C2r plus 1 by 2r plus 2. Yes. Yes. So sigma r is equal to 0 to 5, 11 C2r plus 1 by 2r plus 2 is 2 to the power of 11 minus 1 by 12. 2 to the power of 11 is 2048 minus 1 is 2047 by 12. This is m and this is n. There are no common factors. The GCD is m by n. It is m by n. There are no common factors except 1. The GCD of m comma n is 1. Therefore, m is 2047, n is 1. So, m minus n is equal to 2047 minus 12, that is 2035. The answer to this question is 235. That is the detailed discussion of all these questions that I have discussed in this video. And out of these questions, the question on multinomial theorem and this question, see, they will be tedious, guessing. How do you get the concept of I should integrate that? So even if you have integrated, how should you know that it is to be evaluated between 0 to 1 and then minus 1 to 0? Then you will get an idea that add or subtract something you have to do to get your answer. So these questions, I think 2 of them will take a longer time and will be difficult in the examination hall. Right. I am sure that you understood the solution of these questions. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.